All right, guys, so 2.6, we are doing sort of the applications for some of these exponential and log functions. We're going to start with some interest problems, so dealing with money. The first formula you have here is A equals P times 1 plus R over N to the N times T. I'm going to try to make this a little bigger because I know it's small. That didn't do anything. Maybe. All right, so let's write down what all these variables stand for. So A there, that is the final amount. Like that's the amount you end up with at the end of your investment. Those aren't very clear. P is the principal investment or the initial amount. So it's however much money you are starting with. Okay. R is the rate, like your interest rate. T is time. And guys, that'll always be in years for what we're doing. So let's say you had an investment and I tell you it's invested for 18 months. So you're not going to put 18 in because that would mean 18 years. What would you put in? 1.5. Okay, so just be aware of the problem. You know, what are we talking about as far as time? Don't rush through it. Okay, and then N is kind of the weird one in this. This is the number of times interest is compounded per year. So that's the important piece there. Per year. Yeah.
Just piece thing.
Principal or initial amount. Let's keep those phones away, guys. Oh, you're using the calculator on it? Okay, that's allowed. You don't have to hide that, okay? All right, guys. So let's look at N, number of times it's compounded per year. So if the problem says monthly, how many times per year do you think that's going to be? 12. If it said daily, 365. What about quarterly? 4. Okay. Semi-annually? 2. Okay. Does that make sense? So you're just looking at how many times in 1 year does it get compounded. Okay, so let's do the first one here. So you are starting with $100. It's compounded quarterly for 3 years at 6% interest. I want you to just write what you think the equation is going to be that you're using for this. Okay, so fill in the blanks. So guys, that's the equation you should have. You should have A equals 100 times 1 plus 0.06 over 4 to the 4 times 3. Or to the 12th, that's fine too. Are we okay with 0.06? Okay. It's 6%. Don't put a 6 in because that actually means 600%. That would be amazing interest, but that's not what you're earning. Okay. 6% would be amazing interest right now. Okay, so let's see if your calculator is your friend. Try to key this into your calculator. and let's see how we do. All right, the answer you should be getting. Well, first, guys, it's money. What do you think we should be rounding to? We're not going to go nearest whole number. What can we go to? Yeah, nearest hundredth. We want nearest penny, right? Okay. You should be getting $119.56. Let me just show you. Yay! Let me just show you on the calculator. There are a couple of shortcut keys. So let's see, 6%. All right, so we had 100, and then parentheses, 1 plus. Do you guys know where the fraction shortcut is on your calculator? Okay, hit the alpha, that's this little green key, and then y equals. You guys see this little shortcut menu? That very first one is your fraction key. So take that. And then it was what, 0.06 over 4? If you have an older calculator, you don't have the shortcuts, unfortunately. And then raised to the, you can either type 3 times 4 or 12, does not matter. Okay. The shortcut key is using the fraction part. That helps so that you don't accidentally divide too many things, or, you know, don't divide enough, raise things to the wrong power. You have shortcuts for a lot of things. So you have the fraction. This gets you right to your absolute value, which we obviously don't need right now. But just so you know, you've got log whatever base you want, you can do here. Sigma we'll get to later. Derivatives and integrals, that's calculus. That doesn't do much for you. This one is nice. You guys remember having to store regression equations? That takes you right to your y equals so that you know exactly where you're storing it. If you did it the long way, you had to go to like the vars, y vars, function, all of that stuff. So just some shortcuts. All right, so are we okay with the first one? Okay, if you're having calculator troubles, let me know. And again, if you don't have a calculator, you need to make sure you're sitting by someone who does. So if you have to get up and move, that is fine. All right, let's try again. Okay, so the second one here, how long would it take for $2,000 to double if 5% interest is compounded semi-annually? All right, so we're starting with 2,000, right? What's our final amount if we want it to double? 4,000. So your equation, you're going to start with 4,000 equals 2,000. And then 1 plus your rate over n. What do you think n is this time? 2. Good. What's our variable? Like, what are we actually solving for? T. Look at where the variable is. It's up in the exponent, right? What do you guys know now that you can use to solve? Logs. This is the whole purpose of logs, is so that you can solve an equation where the variable's in the exponent. Okay? Here, let me walk you through this together. We'll erase this. Okay. Your very first step is to isolate whatever is raised to that exponent. So we need to get rid of that 2,000 in front of the parentheses. Yeah.
Are you using the 2,000 for n?
Okay, so that comes from semi-annually. Like if a store says it has a semi-annual sale, do you know what that means? It just means twice a year. Think about semicircle, right? It takes 2 semicircles to make a whole circle. Yep, that's what the semi means. Okay, so we're going to divide by our 2,000. So I get 2 equals 1 plus 0.05 over 2 to the 2 times t. Okay, what do I need to do to both sides of my equation now? Yes, thank you, natural log. You could use log too. I just like natural log because it's fewer letters. So you're going to take the natural log of both sides. From there, the left side is just natural log of 2. Then on the right side, you're going to have 2t, that exponent comes in front, times the natural log of 1 plus 0.05 over 2. All right, stop for a minute. What variable am I looking for here? T. So over on the right, I need to get rid of the 2 and the natural log of all of that stuff. How do you think I'm going to get rid of those? You can divide it all at once. You're going to divide both sides of your equation by 2 natural log of 1 plus 0.05 over 2. Okay, that leaves you with just a t on the right side. Now you're going to use your calculator for the left. Find my calculator. I would use your fraction key. Do you guys see the natural log key? Yeah, Sean. You can write the 1 plus 0.05 over 2 as a decimal if you want to. Don't round it though. So if you're using your calculator, you'd want to store that value, okay? So I would just use shortcut key, natural log of 2. Do you guys see the natural log key on the left side? It's right below the log key. You should be getting about 14 years. I didn't tell you what to round to this time, so approximately 14 years. If you are not getting something around 14 on your calculator, raise your hand and let me come to you. Oh no. Yeah, you walk back. What happened? No, okay, come. Yeah. Yay. Okay. This is only dividing by 2. And I didn't say anything about it. Yeah. Yeah, we'll just say about it. How we doing? Yeah. It does, yeah, because you simplify where it's and then you turn it back. Yes, perfect. We got over here. We recovered from our back. Yes, okay. All right, let's keep going, guys. Okay, we have another formula. This is if your interest is compounded continuously. So, I'm gonna just rewrite those because they're hard to read. A lot of this is exactly the same. We still have an A, we still have a P, but now we have an E to the RT. I call this the PERT formula, okay? PERT, you can do that. All right, A is still the final amount. P is still the principal or the initial amount. R is still your rate. And T is still time in years. Okay, so nothing new there, just a different way of writing it. We don't have an N to deal with this time, okay? This is when your interest is compounded continuously. That means it's compounded so many times in a year that you can't give me a number for how many times it's compounded. So you need to just look for the wording in the problem. So this example, do you see how it's very similar to the first one we did, except it says compounded continuously instead of compounded, I don't know, was it quarterly in our first one, I think? Okay. So just like the first one, try to write the equation for me. We're starting with $100. We're leaving it in there for 3 years at 6% interest. Let's see how we do. And as far as the E on your calculator goes, you guys see here right above natural log how it says e to the x? That's the one I would use, okay? And it makes sense, natural log is base E, they're connected on the calculator for you, okay? So, did you get $119.72? Yes, yes, okay. Do you see how that's just slightly more than what you had when it was compounded quarterly? From the very first problem, okay? So if everything else is the same, compounded continuously is going to give you more money because that money is being reinvested on a continuous basis instead of just once every quarter. All right, so same idea here. Again, we're doubling $2,000, 5% interest, but it's compounded continuously. Do you think it's going to take more time or less time to double? Less time, okay? So hopefully we get something a little less than 14 years. So let's look at our initial equation. Are we okay with 4,000 equals 2,000 e to the 0.05 t? Just like the other one, we divide by our 2,000 first. Have to isolate it. From this step, guys, 2 ways you can think about it. You can just rewrite it as a natural log equation, or you can actually take the natural log of both sides. You definitely want to use natural log and not log this time. Why do you think that's the case? Yeah, we got an e in there, okay? So let's do natural log of both. All right, so on the left here, I've got natural log of 2. Then over here, I have 0.05t natural log of e. Guys, do you remember what natural log of e is? It's just 1, right? E to what power is e? So really, my equation is natural log of 2 equals 0.05t. So how do I solve for t? Yeah, just divide by that 0.05. And I think you get about 13.9 years. Yeah.
So we don't plug it in as 2.7.
No, you don't need to. And the E is going to go away because of the natural log. Does that make sense to you why it just disappeared? Preston, does that make sense why the natural log of E is just gone? Okay. All right. Okay. All right. Let's look. We're a little short on time, guys, so we're going to turn the page here, okay? All right. Our other formulas, with those, we were always talking about money. So now we're going to talk about growth and decay. Have you guys talked about like half-life and things like that in chemistry? Anything? Biology, maybe? So we're going to kind of do some of those problems. We're going to start fairly basic, though. It looks a lot like your PERT formula, except your rate may be negative at this point. That's talking about a decay instead of a growth, okay? Money, we want to grow. We're talking about things that won't always grow. So let's look at the very first one here, maybe. So we have this function here. It says n of t equals 500e to the 0.45t. N of t, that's just saying the number of bacteria over time. It's the same as f of x, it's the same as y, it's just function notation, okay? So if I ask you then, how many are in the culture after 3 hours? What do you think I'm doing with that 3? Just plugging it in for the t, right? Okay, so use your calculator, see if you can get the answer here. And don't use 2.718 for E, use the actual E key on your calculator, okay? Did you get about 1,929 bacteria? Why do you think I'm rounding to a whole bacteria? Yeah, we don't want parts of bacteria. I mean, we really don't want any bacteria at this point, but we don't want pieces of things, okay? So make sure you think about the context of what we're looking at. You know, if we're talking about people, we don't want, 8.2 people. I don't know what that means, so we want whole things. All right, we okay with the first one? Anybody calculator troubles? Like struggling with the E key not working quite right? We're okay? All right, let's look at the next one. All right, after how many hours will the number of bacteria reach 10,000? So what are we doing this time? What are we solving for? T. Yeah, you're solving for that exponent. Okay, I want you guys to try. So your equation is starting out as 10,000 equals 500 e to the 0.45 t. So this is like y equals, so let's think of it that way. The y is there is just like show you the answer. See if we get there. Should have been about 6.7 hours. How'd we do? I see some scribbling. Troubles? Yes.
And then divide by 0.45 and you got it. Well, it wouldn't be by itself, right? So that gets rid of that. And what is that? 1. So that leaves
Okay. All right. I know we only have like 6 minutes left, guys. We can do this. Okay, the next one is where it gets interesting. So let's get rid of this. This. All right. This time we are told a culture contains 1,500 bacteria initially, and it doubles every 30 minutes. Okay, you don't really have the rate. We know it doubles, but it doesn't double every hour, so we can't really just put that in as our rate. So we have to think about finding that K from the formula first. So off to the side over here, I'm going to do a little work. I started with 1,500 bacteria, and it doubles. So how many do I have if it has doubled? 3,000, okay? So 3,000 equals 1,500 e to the K times, how long did it take it to double? 30 minutes. Okay, you have to make a decision at this point. Am I doing this problem in minutes or am I doing it in hours? So what do you guys want to do? Hours, okay. Oh, but look at the question. What did it say we had to do? Sorry, so I misled you. In minutes. So what am I going to put up there for T? 30, okay. So that's K times 30. We need to solve for K. Step 1 is divide. So I get 2 equals e to the 30K. And you'll notice every time if it doubles, that first step is going to be a 2 over there, okay? Natural log both sides, right? So I've got natural log of 2 equals 30K natural log of e. Do I even need to really write the natural log of e? No. So guys, once you start seeing how these work, you can certainly skip steps. So natural log of 2 over 30, that is the value of K. All right with that? That's not what the question asked me for. Okay, it's asking you for the formula. Find a function that models the number of bacteria after t minutes. So a function, so you can say f of x, f of t, I don't care what you use. I'm going to use t just because we're talking time. We started with 1,500. E to the, I know what k is now, right? It's this beautiful natural log of 2 over 30. Times t. Why am I leaving t in the equation? What did you say louder? Yeah, we want to be able to figure out how many bacteria after any time that we're looking at. Sean?
Why would we simplify the ln to
Like to the decimal value?
Yeah.
You can, if you're going to do that though, store that value on your calculator. Okay, because otherwise you're going to be using a rounded answer to find another answer. So like double rounding in a problem is not a good thing. If you want to, you certainly can just store it. Okay, so one last quick one we're going to do. Find the number of bacteria after 2 hours. So what am I going to plug in for t? Am I going to put in 2? 120, good. So just key this in, natural log of 2 over 30 times 120. I don't remember what it was. Let's see real quick. Did you get 24,000? Okay. Yikes. Okay. Rapidly running out of time here, guys. Does that make sense what you have to do on that type of problem, though? You've got to find K first when it's growth and decay? Yeah. So 2 hours is how many minutes? That's all. Yeah. Because we wrote it in minutes. Okay, homework, guys. Jot it down real quick. So if you haven't finished, that's a 2. The 2-4 and 2-5 that was assigned last time, you need to finish those. And this front of it, just do the evens. Back only number 2, 4, and 7. Okay? Front is all the financial stuff. So that's just practice plugging into those formulas. The back is the weird K stuff.